Cool. Good luck.
Hey everyone, I am here with another amazing company on episode number 7 of the podcast. I got Moshiel from Addionics, right? And he
Yeah,
he has an
right.
amazing company. Please, Moshiel, tell me about yourself and just introduce the company.
First, thank you very much for the opportunity. It's a great pleasure
Of
to
course.
be here. And yeah, my name is Mushiel. I'm the CEO and co-founder of Addionics. We are a battery startup company. Started a company 5 years ago. We are almost, I would say, more than 40 employees. We raised almost 40 million US dollars.
Wow.
And working with the large leading automotive player in the world to develop the next generation batteries. What we do, we change the architecture of the battery in order to improve performance and to reduce costs.
Wow. Okay, so these batteries, let's say, are they used for like electric vehicles? Is that what we're looking at?
Yeah, so we are developing a component that is suitable for any type of battery.
Gotcha.
It's a chemistry agnostic solution, so suitable for any battery format and any battery application as well in any domain. Our main focus is automotive, but our solution is also suitable for other applications. And this is our vision, is to integrate our technology solution inside every battery in the world.
Gotcha. Wow. Now, tell me how you get started in this type of field? You started this company 5 years ago. What happened before that? Like where's your knowledge in batteries? Tell me, yeah, where this all start from?
Yeah, so my background, I'm a material scientist and studied like materials engineering at Ben-Gurion University in Beersheba, Israel. And honestly speaking, I was mostly focused on metal, semiconductors, and nothing related to batteries. And my master supervisor back then tried to convince me to pursue to a PhD. And I didn't want to let him down, so I told him if I will do a PhD, it's only abroad and not in the same university. And fast forward, I found myself at Imperial College London doing PhD, and the research was on batteries. So already 10 years in the battery domain, so it was more than 10 years. And when I moved into the battery field, and that was completely new for me. I didn't know anything about batteries. Battery for me were like batteries that you have for remote controls and toys. And batteries was, I think the topic wasn't sexy or trendy as it today. And also in Israel, it was the days where Better Place fell and the collapse of Better Place. So electric vehicles, the concept wasn't, I would say, alive or I would say acceptable as it today. Today, everyone is talking about electric vehicles.
Yeah.
The train left the station, so the
Correct.
Revolution is already happening.
Correct. So you started learning about batteries before it became like all hot. You were there in the beginning. So you got your PhD in batteries. Is that what you're saying? Like, wow, that's so interesting.
Correct. So the research focus was to better understand the relationship between the battery architecture to the battery performance.
Gotcha.
So to link it, and we were one of the first research group in the world that invented methodologies to analyze and image batteries in real time. So during the operation of the battery, we saw inside what happening. Similar to, you have an X-ray or MRI, but you also have fMRI, functional MRI, that you can, I would say, image the patient and while he's speaking, and you can see where, what areas in his brain are operating. This is exactly what we did for batteries, and were the first researchers. The co-founder of the company, they used to be my PhD supervisor, and they invented those, I would say, methodologies. Farid, which is the CTO of the company, is one of the first researchers in the world that developed imaging and analytics for batteries in real time. And Vlad, the other co-founder, is a battery genius. So he's with years of experience in batteries, formerly from Tel Aviv University, and later on used to work at Imperial College. So all of us met at Imperial, all the co-founders.
You guys are like the super team of batteries. You're a doctor of batteries because you got your PhD in batteries. Wow, that's so we got the team creating these batteries. Now, after like, so you've been working on this for 5 years, right? Now, when did you actually develop the batteries? Obviously, I don't know, did you develop it in the first year? Did it take you a few years? Like right now, you have batteries. Right now, you're using your own batteries in companies, right? Companies are using your batteries. Tell me about the progression of like how long it took to create the battery. When did it start being introduced into cars or other places?
So right now we are in the integration phase, but of course it wasn't a magic and not happened in one day. Also, it's important to note or to remember that batteries is a tough, challenging system. It's a multidisciplinary system containing electrical, mechanical, thermal, electrochemistry, all those materials, all of those aspects involved in one system. And it's challenging because you have many variables included in that system. And mainly the main challenging is to stabilize the battery chemistry, the anode chemistry, the cathode chemistry, the electrolyte. It's lots of optimization and iteration in order to find the optimized parameters and to stabilize them. So usually it's very convenient to have like an analog, like pharmaceutical industry. So they develop a battery, it's similar to developing a drug. So, and our advantage, and the reason that we have relatively faster time to market is the fact that there is no need to synthesize new chemistries. We're only changing the architecture of the battery. So in every electrode, you have two components. You have the active material, the chemistry, and the current collector. The current collector is usually a 2D metal foil, and we are changing the structure when the metal foil is not completely dense and 2D anymore. We are creating a 3D structure, and in that way, we are increasing the ability to load more material. We are creating more real estate in the same volume, and also increasing the surface area simultaneously. So this is giving us a huge advantages in the performance, but also with the ability to reduce the cost because we invented a novel manufacturing process to create a 3D structure. And that's the core IP. And we have another part of the IP which related to the modeling and the understanding how the structure affect the performance. And this is related also to the background in batteries that I mentioned as one of the first researchers to really a link between the structure to performance. And the other pillar of IP is the process engineering, is how to take those structures and integrate it together with different types of chemistries with minimum friction. So the idea is to present a huge impact, but with small changes on the production lines or on the chemistry, etc. So to be able to integrate into existing production line, which is a huge advantage in order to utilize the capex that is existing today. So I think you asked about how we started and what is the process. So at the beginning, it was very tough. Everyone told us that we are crazy. It's never going to work. You'll face
what's so unique about your process? Because of 3D version of a battery, that they thought you couldn't do that.
So yeah, the concept itself is not unique.
Yeah.
The structure to go to 3D, it's quite known and quite, I would say, it makes sense as well.
Yeah.
The semiconductor industry doing that for years, and the battery industry failed to take the same, I would say, approach. And the reason for that, because at the end, batteries are commodities. They need to be very cost effective.
Correct.
And the foils today are similar to the foil that you have in your kitchen in terms of cost. You know, you need to have some structure that you can wrap sandwiches with them.
Correct.
So they need to be very, very cost effective. And in that way, all the alternatives that people try to use, what was available, it wasn't suitable for the battery market. It was very expensive, non-battery graded, non-chemistry agnostic, and not scalable enough. So we did understand as battery scientists that in order to integrate new technology and new structure into the battery market, you need to have a cost-effective process, highly scalable, battery graded, and chemistry agnostic. As foils today are in every battery in the world, you have copper foil on the anode side and aluminum foil on the cathode side, and the same analog, the goal and the vision was structure that will be in every battery in the world. And in order to have in every battery in the world, we kind of walk backwards and ask ourselves, okay, what we need to achieve. And that's why what we invented, we have a novel process that is enabling to move to 3D structures.
Gotcha. Wow. And you created it in a cost-effective way, obviously, which no one thought you can do. That was basically probably the biggest challenge, getting these batteries to be to be not too expensive so that people can actually afford them to put into everything. Now, what's the focus right now? What are you focusing on? Batteries for cars? Are you focusing on batteries for smaller electronics? What's the focus right now?
So the main focus is electric vehicles, EV, battery electric vehicles, but we also have projects related to other applications, micromobility, consumer electronics. So yeah.
Now, do you have any companies actually using, let's say, in the electric vehicle space, like any car companies using your batteries in their cars?
No, not yet. Today we've announced a partnership with electric scooter in order to demonstrate and to have batteries in the scooter. We have also other micromobility projects and other projects with automotive companies, but they are not public yet.
Correct. So they're working on integrating your batteries into their cars, but obviously it takes a lot of time to for that process to happen. So, but it's in the works. Soon we will see Addionics batteries in cars, right?
Our plan is to demonstrate our technology in a live environment, in a live demo.
Yeah.
So you'll see a vehicle that is running on our structure.
Okay. Wow. So okay. Okay. So really, first of all, I don't know. I don't know anything about batteries or anything. So what you were saying is a little like, I was trying to understand everything you're saying. So can you just break it down? I think I understand it. Can you break it down for people who may not understand batteries? What is unique about Addionics batteries, and what differentiates your batteries from, let's say, other companies? Because again, there's probably hundreds of companies or thousands, I don't know, that create batteries or make batteries. Tell me just in simple terms, what makes you guys different? But like really simply.
Yeah. So most of the companies, they focus on the battery chemistry.
Yeah.
And while they focus on the chemistry, we focus on the battery physics.
Okay.
On the structure.
The structure. Okay, creating the structure.
Yeah. So maybe let's go back and to explain to the audience what are batteries and what battery is made of. So battery, it's a closed system which can store energy. Lithium-ion batteries are, I would say, it's called secondary batteries that you can charge and discharge.
Correct.
And you have in a battery a few main components. You have electrodes, anode and cathode, so negative and positive electrode. You have a separator that separates between the electrodes because you don't want to have a contact, electric contact between the negative and positive. Otherwise, you will get a short. And you have electrolytes. So it's a medium that transfers the ions from one side to another side.
Gotcha.
Think about like, musical chairs game.
Okay.
When you charge and discharge, and each electrode consists of two components, as mentioned before, the chemistry, the active material, and the current collector, which is a 2D metal foil. So what's unique about Addionics is the production and understanding how changing of the current collector will change the electrode structure and change the battery performance. So we're creating 3D electrodes that the active material and the current collector, they have higher surface area and can load in the same volume more active materials. So we're creating real estate. And we believe that the geometries of batteries today, the sandwich layer structure is not optimal. And we can optimize the architecture in a way we can, set it up in much more efficient way that can improve performance and reduce cost.
Now, first of all, are you on a laptop? Can you, is there any picture you could pull up of, like, let's say a battery, the inside, like, I don't know if you have like any like pictures of like what the battery looks like, what you're trying to explain to me, because it's like a 3D, right? The 3D image. Do you have anything that you could pull up?
Yeah, I can share with you later.
Okay, no, yeah, because okay. Now, so why do companies want your battery? Because it's besides for being cost effective, is it I don't know how to say, is it quicker? Is it does it have a longer battery life? Like what pulls companies towards Addionics?
Yeah, that's a great question. So also it's important to see the shift that the industry is, I would say, having at the moment. A few years ago, it was more a performance discussion. So everyone wanted to have the best battery, which gives you the best performance.
Mm-hmm.
And right now we're facing shortage and issues with supply chain and prices, which was opposite to the previous trends. The first time that in the 10, 20 years that the cost of battery is going up.
Yeah.
And that's create like panic. And, the train left the station, as mentioned. Companies, car makers already announced of moving into carbon zero to have only electric models. And this is put lots of pressure from government, from car makers. The energy prices today with the geopolitics, war in Russia, etc. Of course, it's pushing also batteries and electric vehicles. So the discussion has changed more about first how we as a buyer or as a producer can secure the supply, can make sure that we'll have enough, and second, the cost. And with our technology, we found a way to reduce the amount of inactive material. And by that, we're increasing the energy density, but also lowering the amount of inactive material. In that way, we can lower the cost. For instance, if we take a metal, copper, and can we make it, we can save 30% of the metal, of the copper in the battery, it means that we can lower the cost. And that's something which is very attractive today.
Gotcha. So that's
and in terms, today the discussion is more about cost, supply chain, etc. But of course, the main advantages is the ability for us to load more active material and simultaneously to make sure that we have high contact to high power. So to minimize the energy to power trade-off, we can extend the energy density and to lower the internal resistance, which is equivalent to improve the fast charging.
Interesting. So it's about cost, but it's also about the battery performance itself. I feel like you guys offer two advantages. And yeah, right now everyone wants batteries, they need batteries, but I don't know how much copper went up or all these, but they definitely went up significantly in the past year or two. So every penny counts, I guess, with the batteries, and also the density of the battery in order for it to be lighter and more efficient. Wow. So you guys came in at the right, you guys are here at the right time. You guys are here at the right time with your batteries.
Yeah, correct. So timing is everything.
Yeah.
Or in that case, of course, we are lucky.
Yeah.
Something that we should always have.
Yeah.
That luck. Probably it's the best time in the history so far to be entrepreneur in that field.
Right.
And there is more interest, more people even claim that the next unicorns will come from the energy field. And we
Right.
see that. We see companies that following that route. We see like how I would say huge companies deciding also to invest in energy, in batteries, in production of batteries in-house. Many car makers like building batteries by themselves.
Right.
And that's definitely like a privilege to be in that sector today. And what is important is to understand that all those companies, they want to move upstream and to a vertical integration. And they understand that the building block of a battery is the substrate that you put the chemistry on top of that. So this is the current collector. Usually it's dominated by legacy metal companies that building those metal foils without major differentiation. It was overlooked, I would say, component in battery research in the last 30 years. Just a minimal number of even research being done in that area. And that creates also opportunity. If something was overlooked, for us, we feel that there is a huge room of innovation and differentiation. Right. And also there are lots of batteries today that, companies, research centers, universities try to squeeze already everything from chemistry. Yeah. So really like to try to take the last drop always. And the innovation is incremental. We don't see a leap for major changes. And we really think that with this component, with the physics, it's the only way to unlock the potential of batteries.
Wow. Now, what do you see the future of these? What do you see the future of batteries? In general, like let's say looking down the road, let's say 5-10 years down the road, do you see most companies, let's say in regards to vehicles, trying to switch over to electric vehicles? Do you think it's even possible for so many things to be electric? Is there even enough copper to even like create all these batteries? It's like it takes a lot of components to create these batteries. If everything was electric, is that even sustainable?
So yeah, what I believe, like the price is not going to be normalized very soon. It will take some time to have normalization and then price drop, which will take some time. It's not going to be a magic. I don't have a crystal ball to tell you exactly when it's going to be, but that's going to be the trend. This is also the shortage and the issues that we're going to face in the next few years will create opportunities to adapt novel technologies. So this conservative market will be more open to adapt new technologies. I think the fact that more competition is entering into that field and more parties are joining the party, so that's going to put lots of pressure and create also motivation to adapt new technologies.
So you're saying in the future, the technology obviously can get better and better because of the competition, because it needs to be.
Yeah, I think the competition, also most of the batteries today, they produce in China, and this is also going to change. we see that the West, Europe, US, they are building batteries in an exponential growth,
Correct.
much more than they did before. And they understand that this is a national security, like batteries, not for electric vehicles, it's also for energy storage in the grid.
Correct.
If you want to remove the dependency of oil or other polluted fuels, and you want to use batteries, you need to understand, or green energy, you also want to understand how to store. So energy storage is a huge vertical, and it's national security, like every other energy component. And that's something that the government understand that they need to have that onshore and to build batteries in-house. So the US and also Europe started trying to build batteries, and it's growing very fast.
Gotcha. Okay, so that's there's gonna be a lot of growth in regards to you know, or countries trying to create their own batteries in order not to be dependent on anyone else. That makes sense.
Yeah, and this is also create opportunities because if you want to compete with China, you'll not be able just to copy paste. You need to adapt
Correct.
new technologies, innovation,
Right.
and companies like us that developing new concepts and new innovations are definitely the answer to, I would say, having a competitive advantage.
Interesting. Wow. Now, so the company you said you have 40 employees, right?
Yeah, and growing. Yeah.
Wow. Yeah, because I assume that at this moment 40 is a lot, but you know, I'm assuming you see it growing a lot bigger when as the demand grows for the batteries and as you introduce them into vehicles and other small anything. Wow.
Yeah, so we're growing aggressively and globally. We
Wow.
have team in London, in the UK, in Tel Aviv, Israel,
Yeah.
and now opening like also expanding to Germany and to US
Wow.
with new hires there. So
Yeah.
definitely operating global to be closer to our clients, to our
Correct.
subcontractors.
Correct. Wow. Now, wow. Very it's very impressive. Especially the company, 5 years is a long time, but it's also not such a long time for to create such an amazing, you know, technology. It's not that long. I mean, 5 years is a long time, but wow, very interesting. Now do you have, what's the vision for your company? Do you have a where do you see yourselves, let's say in like say the next 5-10 years? Do you see yourselves integrated into lots of do you see your batteries in a lot of in a lot of cars? What's your vision?
So the vision is to see our technology in every battery chemistry, in every battery domain, in every battery format.
Yes.
So really to be in every battery in the world
Yes.
in order to create a better, I would say, planet. But of course, it's not going to happen in one day. It's very aggressive and ambitious vision, but we have also a very solid plan in order to achieve that.
Wow, I'm very I, I feel like you guys are ready. You guys are there. You worked very hard to create what you created. And now when people just need to adapt, they need to, you know, adopt your batteries. And once they see that they're better, they're more effective and they're more efficient. I mean, I see companies wanting it. Maybe governments too. I'm not sure. You know, a government may want to buy you out. They may just want to be like, we need you. You guys are the forefront of battery technology. So that's very cool. That's
And
very
thank you
cool.
very much. We're still like, of course, working hard
Of
and
course.
committed to work hard in order
Yeah.
to achieve that. So it's
Yeah.
still like the journey
Yeah.
is, at the beginning.
Yeah.
We don't see like that we have like, as I mentioned, very large ambitions,
Correct.
and it's not going to stop anytime soon.
No, wow, I'm very excited. I see the vision, and batteries are honestly the new forefront of technology because, you know, they're everything. Everything needs batteries. So very excited to see Addionics grow and, you know, be everywhere. And Moshe, thank you so much for your time. It's been really interesting, super interesting. I didn't know anything about batteries, and now I learned a lot more than I knew. So thank you so much. And yeah, I can't wait. I can't wait to see you guys, you know, be everywhere.
You're welcome. Thank you very much. It was a great pleasure and really happy to speak with you.
Thank you so much.